Hi guys, so in this lecture video I am going to tell you about how we are going to derive the shape function for 4-noded tetrahedral element shortly called as TET4 and hexahedral element shortly called as hexa8. Okay, so this syllabus I told in the beginning only. Okay, so question they may ask you like this. Okay, derive shape function for 4-noded tetrahedral element. Okay, so consider this is a 3D solid element. Okay, so having 4 nodes 1 2 3 4. Okay, each node having 3 degree of freedom. Okay, that is one is x y z. Okay, so I shown here x, this is a x y z 3 object. Okay, 3-dimensional object here. Okay, so this is a how many faces will be there for this 4 noded. Okay, so having 4 node will be there 1 2 3 4. Okay, so here look at the in 3 dimensional. So the normally the displacement, how you are going to write the polynomial function, what? So u is equal to xy comma z is equal to uvw. So 3 direction, so start from a naught plus a1x plus a2y plus a3z. Okay, so here 3 4 5 6 7 8 9 10 up to 11. Okay, so 11 of z. Okay, so I have to write it. Okay, a naught plus a1x plus a2y plus a3z plus again a4 plus a5. So this can be, I already told you, with the help of the Pascal triangle. Okay, so that the magic triangle we are going to write this polynomial function. Okay, so in the same manner the formulation of CST element we have. So how many degree of freedom will be there? So each node having 3 degree of node, each node having 3 degree of freedom. Okay, so here in the same manner CST element, so u of x comma y comma z is equal to 1 by 6v. Okay, so here degree of freedom will be for the first phase. If you consider first element means, so you are going to get the 6. Okay, so here v stands for the volume. Okay, so 1 by the whole divided by 6v. Okay, alpha 1 plus, okay, beta 1 x plus y gamma. This is what alpha 1 beta 1 gamma 1. Okay, so alpha 1 plus beta 1 x plus y, gamma 1 y1 plus delta 2 z into u1. So this is what the un displacement. Okay, this is u2 u3 and u4. Four nodes are there. Okay, u1 u2 u3, let us assume this. Okay, so where u1 u2 u3 be the nodal displacement at node number 1 2 3 in different direction, that is x y z. 4 direction will be there, 4 right on here. Okay, and v is the volume of the tetrahedron. Okay, and 6 v is given by like this. Okay, so same you have to write in the this fashion. Okay, so this in the tetrahedral 6v is given by 1 1 1 1 x1 x2 x3 x4 y1 y2 y3 y4 z1 z2 z3 z4. Okay, so give you question number 1. So if you after substituting this, you have to calculate the coefficient of the given matrix. Okay, so that is what alpha 1 is equal to x2. So just to eliminate. Okay, suppose for considering the first element, you eliminate this sign, this, so remaining you have to write on. Okay, that is x2 y2 z2 x3 y3 z3 x4 y4 z4. Okay, so after deleting this first row first column, remaining things you have to write this is alpha 1. Similarly beta. Okay, so beta is the opposite direction, minus. Okay, so here y2 y3 y4 y2 y3 y4 is there. So y2 y3, so this one they are eliminated. Okay, this one you have to eliminate as the first row. Okay, so remaining right on. Okay, like this you have to write the alpha 1 beta 1. Okay, that is gamma 1 alpha 2 beta 2 gamma 2 gamma 2. Okay, so like that you have to write all the 4 nodes. Okay, so 1 2 3 4 nodes. If you wrote like this means the finally all those, with the help of all those elements, you are going to take what write in matrix form. Okay, so u 3 direction will be there, u1 v w. So n1, so again 00. So here nothing will be there, just you write these in the matrix form. Okay, so the final this one is right in the matrix form. Okay, so n1 0 comma 0, n2 0 comma 0, n3 0 comma 0, n4 you are going to get. So 3 display, so displacement you have to write here. Okay, so like this up to 2 3 also you write u1 v1 w1 u2 v2 w2, like this you have to write up to 4. Okay, so here where n1 going to what the shape function. Okay, so that is what the alpha 1 plus beta 1 x plus gamma 1 y plus delta 1 z. Okay, whole divided by 6p. So like that the write on the shape function. Okay, where n1 stands for this and n2 stands for this, n3 stands for this and n4 stands for this. Okay, so these are the shape function for tetrahedral element. Okay, you have to remember this is a very important derivation is there. Okay, so here the main thing is how to write this. Okay, that is most important here. Okay, so next one is you are going to again same second one is what to calculate the shape function for this hexahedral. Okay, so hexa means what? Can hexa means, okay, hexahedral element. Okay, so here consider a 3D object. Okay, if you look at the 3D object first here. Okay, below figure shows what the linear tetrahedral element. Okay, in both the global coordinate and Cartesian coordinate. Okay, so look at here, this is the first one is a global coordinate system. Okay, so here look at this is how many nodes are there? 8 nodes are there. They are told the hexa 8. Okay, note down this 8 hexa nodes will be there. Okay, Okay, so look at here. So 8 below figure shows the hexahedral element both in global coordinates and the natural coordinate system. Okay, so this is the node number 1, 2, 3, 4. There is a three-dimensional object. You have to write a this element. Okay, so here look at the consider here here they are considering from x1, y1, z1. Okay, x2 where is x2 here? Okay, so this is point x2, y2, z2. Okay, so x3, y3, z3, three direction will be there. Okay, like that you have to write on here the values. Okay, so that is in the local coordinate, natural coordinate system you are going to denote as what? Zeta, eta, eta. Okay, so here look at this at point number, this is the nodal. Okay, so initial okay, at node number values are -1, -1, 1. Okay, and at node number 2, so how we are going to write this -1, 1, 1, -1? Okay, you look at position number 2, so this is a backward is there. Okay, so backward means just you observe the values are minus, minus, minus. Okay, so you stand here and observe the values. Okay, so I am coming to the here. Okay, this side, this face, first face is always front, so write positive, remaining the two faces will be back side, so write negative value. Okay, like that you have to write on the all the values. Okay, so this is in this is a global coordinate, this is a natural coordinate. Okay, in natural coordinate we are going to denote the distance. Okay, what the origin is, what we are going to denote the center of the element. Okay, so look at here, you are wrote the -1, -1, 1. Okay, this one. Okay, this face will be there back side. Okay, so that what the remaining x and y should be negative, and the front face will be going to positive. Okay, so consider at this face. Okay, node number 3, so node number 3 completely the back side. Okay, so that is zeta values. Okay, so completely the back side we are going to completely the 3 is the middle will be there. Okay, so completely back, and the third node will be visible in the third position. Okay, so this face and this face value is going to negative, negative, and the plus 1 is. Okay, even if you add these two you are going to get plus 1 only. Okay, the maximum value of the shape function is what? Plus 1. Okay, so after writing this, okay, so use the polynomial function in terms of the global coordinate. Okay, so this I told you in the magic triangle. Okay, so note on these values polynomial function. So u of x comma y comma z and v of x comma y comma z and w of x comma y comma z. Okay, so write on a0 a1x plus a2y plus a3z plus a4xy plus a5yz plus a6zx plus a7xyz. Okay, so this can be write in a what the magic triangle. Okay, so here three direction will be there, so this is along x and this is y, z. Okay, three displacement will be there. Okay, the shape function in terms of the natural coordinate system is given by this standard formula. Okay, so in this formula you have to substitute all the values. Okay, so this is at node number 1 shape function. Okay, so zeta values what? Zeta value is -1, eta value is -1, eta value is 1. Okay, so these values substitute in this equation, so you are going to get shape function for n1 is equal to 1 by 8 1 minus zeta. Okay, so like that you have to substitute all the 8 faces values. Okay, at node number 1 you put the values this, at node number 2 you put the values -1, -1, -1. Okay, zeta values. Okay, so zeta. Okay, so zeta I is nothing but what? The front -1. Okay, so here eta I nothing but what? This the third direction +1. Okay, and eta value is -1. Okay, substitute in this formula you are going to get this equation, that is shape function for 8 nodes. Okay, so n1 is equal to n2 is equal to n3 n4 n5 n6 n7 n8. Okay, so these are the shape function for hexahedral element. Okay, so you have to remember only the values here. Okay, so I will repeat again here how to remember this. Forget about this global stiffness matrix coordinate system, you have to remember this. Okay, look at here. So I already told in the natural coordinate system the value should be measured at the center. Okay, so consider here this is this side along this direction is going to denote as zeta, and this side is denoted as xi, and this side is denoted as eta. Okay, so if you observe, okay, so this is a okay, so this was what the at node number 1 what? So this side will be back side, so zeta z direction is back side will be there. Okay, and one more is x direction. Okay, so x direction is front. If you looking, it look like a front side. Okay, so this eta, so this eta and zeta value going back side, and this is the front side. Okay, so right here this positive value, and this side negative value. Okay, okay, consider point number 2. So this point number 2, all zeta, eta all values are back side only. Okay, just to observe back side, so all values are going to get negative value. Okay, so like that you have to write all these values. So substitute at node number, each node number 1. Okay, so zeta, eta, zeta y, so substitute means you are going to get this shape function. Okay, n1 n2 n3 n4 n5 n6 n7 n8. Okay, these are the shape function for hexahedral element. Okay, like this you have to derive these equations. Okay, so I hope you understand this. Okay, thank you.